Everybody, welcome back to another fun and exciting geometry class. Today we are going to be talking about lesson 2.22. That is in your book on page 102, and we're going to be talking about polygons today. Polygons. Poly comes from a Greek word meaning many, um, like many gods. They would polytheism. They would worship more than one god in their culture. Um, we obviously know that that's not right, that there's only one true God, and we worship that God, the God of the Bible. And but in their culture, they worshipped multiple gods. Polytheism, many gods. We would believe in monotheism. Um, so basically, the idea is that it's just multiple sides, many sides. Poly, many sides. Polygon, many sides. So a polygon can be 3 sides, a polygon can be 10 sides, a polygon could be 1,000 sides. There's no limit to how many sides a polygon can have. And the book kind of goes through and it tells about some of the different polygons. I'm going to show you this graphic. If you look down at the screen, I show a graphic of different types of regular polygons. The first one is the triangle. We're going to wait on the angles over here on the right hand side. I'm just going to talk about the type, the sides, and the shape right now. And then we'll talk about the angles a little bit later in the lesson. So we'll come back to this. But the triangle has 3 sides. We've been working with that a lot. The square. Um, the pentagon has 5 sides. The hexagon has 6 sides. The heptagon has 7 sides. The octagon has 8 sides. And that's really about the end of where you would typically talk about shapes by their size. Octagon is pretty famous because of several different reasons, but maybe you've seen MMA or like the wrestling things, and they talk about the octagon. Another one is the stop signs. They are done in octagon shapes, 8 sided. Um, Typically, you don't see 9, 10, 11, 12 sided shapes, but those shapes are called 9 is a nonagon, 10 is a decagon, kind of sounds like decade for 10. And 11 and 12 in your book, they're called one thing. And for the most part, like outside of your book, or if you look it up online or something, you're going to see something different. So in your book, it's called an undecagon. Okay, the 11 sided is an undecagon. But here it's a hendecagon. So just whichever. Again, you hardly ever use that, so it's not that big of a deal. Number 12 in your book, the 12-sided shape is called a duodecagon. Duodecagon. And in your book, it's called a dodecagon. Okay? Duodecagon or dodecagon. Either one of them kind of interchangeable there. Again, not that big of a deal. The big deal is that you know 3 through 8. Okay? You need to know those shapes 3 through 8 and by size. Again, these are all polygons, closed shapes, 3 or more sides. You can't close a shape with 2 sides. You have to have at least 3 sides to close the shape. Okay. All right. Well, if again, we're on page 101 or 102 and 103 in your book. So if you want to look down there, just kind of follow along. Some of the key words here, vertices, it throws that word in there. Make sure you know what a vertices is. It's the vertex. It's the plural of vertex. It's where the angles come together. Okay. Sides, obviously, we know what sides are. We should know what sides are by now. Angles, we should know what angles are. Make sure that you do pay attention to this. You can look down here at the screen and I'll show you. Sometimes you have interior and sometimes you have exterior. We've already talked about this concept, but here's the idea. In this one right here, you would have an interior. Okay, this one inside here is the interior. This is the inside of the shape. Okay, that's the interior of the shape. So this one, this one, and this one. Those are the interior angles. Well, something that's interesting about polygons is you're also going to have exterior angles, but you actually have two sets of exterior angles. So look at this. If I extend this line, I end up with an exterior and outside. And then I extend that line, and then I extend this line, and then I extend this line. And I end up coming up with exterior angles. But look what happens if and I've already extended those lines, but what if I extended these lines? Basically the opposite that I extended on the other one, because there's two lines there. So really you have two sets of exterior angles. But for the most part, you're only going to use one at a time. You wouldn't use both sets of exterior angles. You would choose, okay, I'm going to use this exterior angle right here, or or I'm going to use this exterior. You would pick which set you use, okay? And you can see a picture of that on page 103 in your book, page 103. The next thing we come to is informal statement number 15. Informal statement number 15 says, in any polygon, the sum of the exterior angle and the adjacent interior angle at each vertex is a straight angle. So let's pick a vertex. We'll pick vertex A. I like vertex A. I don't know why. I just picked A. You could have picked B, C, or D. Any of them would have worked. So if we take the exterior at vertex A and we add the interior at vertex A, what do we come up with? Well, we come up with a straight line. So exterior plus interior, so exterior plus interior is always going to equal 180 degrees. It has to, okay? Because it's a straight line. This is a straight line, so your interior plus your exterior will equal 180 degrees. It is a law. It has to happen. All right, next, informal statement number 16. In any polygon having n vertices. All right, well, what in the world is n vertices? Well, here's another polygon. And this polygon has how many vertices? Let's just number them. 1, 2, 3, 4, and there are 5 in this one. Okay, and so what is that called? Do you remember? The Pentagon. Okay, 5 has a strange name, I guess. It's not the Fiveagon or something like that. It's the Pentagon. There's one of these buildings in Washington, D.C., and the building is kind of shaped like this, and then on the whole interior right here is like a courtyard garden area, and then the building is all around here. It's a pretty neat building. It's the government building in Washington, D.C., like the defense, Secretary of Defense is in there. It's basically like the generals and all that different stuff. So you can look it up. Look up a picture of the Pentagon. It's a neat building. Informal statement number 16. That's where we are. I got a little sidetracked there. Sorry about that. In any polygon having n sides, that is n vertices, that is n sides. So now we've numbered our vertices. Let me go back through and let's number our sides. Now watch this. 1 side, 2 sides, 3 sides, 4 sides, 5 sides. Okay? So if it has 5 angles, guess what? It's got 5 sides. If it has 4 angles, has 4 sides. If it has 10 angles, it has 10 sides. That's how these things work. The sum of one group of exterior angles and all the interior angles of the polygon is n straight angles. Well, how many is n? Well, in this one, n is 5. So if we count up all of the exterior angles, so I'm just kind of going around it and making exterior angles. So if we count this one, this one, this one, this one, and this one, there's 5 exterior angles there. And we count all of the interior angles right here, we are going to come up with 5 straight angles. 5 180s, if you will. Okay, so that's an interesting thing. Not that big of a deal, but we'll kind of connect on that here in just a second. let's turn the page over to page 104. Page 104, we're actually going to continue talking about this shape right here, this pentagon. I'll just leave this one here. This one is what's called a regular pentagon, a regular polygon. What is a regular shape? Well, we've learned about regular, different things that are called regular. Well, if something is called regular, then it's like matching. Everything is the same. There's nothing weird about it. In other words, if this side is 6, then 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 this side is 6. That is a regular pentagon. And it could be anything. Those sides could be 8, 8, 8, 8. But what I'm saying is you can't have one that is 7. Okay, then that would not be regular at that point. What makes it regular is that they are all the same. Every side is the same. And notice what it says there. A regular polygon is a polygon that is both equal angular, so these angles all are the same. In other words, that's equal to that's equal to that's equal to that's equal to that. They're all equal. Every one of those angles is the same. So maybe it's, I'll just throw something out there. It's like 130 degrees or something. Well, all of them would be 130 degrees. We're going to figure out I know what it is, and it's not 130, but we're going to figure out how to tell what the degree is in just a second, and that was on that chart that we looked at earlier. But we're going to actually find a little formula. And today's kind of a neat day because usually we don't get to do math in geometry class. But today we're going to do some math in geometry class. So here's the trick with this. If it's a regular, okay, so if they're all matching, if all the sides are the same, if it's equal angular and equal lateral, okay, Theorem 26, it's on page 104. It says the sum of the angles of a polygon of n sides is n minus 2. So if we take n minus 2, now what is n? N equals the sides. Or the angles, you could have it be either one. In this case, n equals 5 because there's 5 sides. Okay? And so if we take n minus 2, we would get 5 minus 2, and we would get 3. So there are, in this, there are 3 180-degree straight lines. Okay? And the sum of all the angles of the polygon is, so if you were to measure all of these angles, you would come up with 3 times 180. Okay, or if I take out my calculator, I would end up with 3 times 180. And that would give me 540. So there are 540 degrees in these angles. Total. Okay? If you add all those up, it's going to equal that. So now the question is, well, how much is each one? Okay, well, this is corollary 26.1, which is on page 105. So how much is each one? Well, if there are 5 sides, and let me change this because it doesn't matter because there's 5 sides and 5 angles. I'll change this to n equals angles. It'll be a little easier for what we're doing right now. So if n is 5, well, if I take this total number of degrees and I divide it by 5, so if I have n over 2 divided by n, okay, that's going to tell me how many degrees are in each angle, each actual angle, not in the total, because now I'm dividing it by 5. So again, n is 5, so 5 minus 2 over 5. Okay, and then so we'll go back over to our calculator, and we'll just divide that by 5. Divided by 5 equals 108. 108. So 108. Each one of these angles is 108 degrees. Okay, every one of them. Total, there are 540 in the thing. Each one specifically is 108. So let's go back down here to this and we look at our pentagon here. So right there is our pentagon and it's 108. Okay, so a five-sided shape has 108 degrees in each angle. Let's look down at the octagon. Okay, I've got an octagon that I'm going to show you next. Octagon right here is eight-sided, 135. Well, how do we figure that out? Let's go back to the octagon that I have here. And let's plug into our formula. What's our formula? N minus 2 over n. Make sure you know that formula. That's an important formula. Okay? And then we're just going to plug into it. What's the n? Well, the n equals 8 because there's 8 sides. There's 8 angles. Okay? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. Okay? It's like a stop sign. So we're going to go ahead and plug in with 8 this time. So we would have 8 minus 2 divided by 8. And so if we go ahead and do that on the calculator, and then it's always times 180. Okay, that's what the formula says, because it says corollary 26.1. In a equilateral polygon, the n sides of each angle is n minus 2 over n straight angles, or times 180, times a straight angle. Okay, and so let's go ahead and do this. Let's put 8 minus 2 divided by 8. So 8 minus 2 is 6 over 8 times 180. And I could reduce that if I want to. I could reduce that to 3/4 times 180. So if I go to my calculator and I do 3/4, 3 over 4 times 180 gives me 135. So 135. Each one of these angles is 135. Well, let's do this. I put the total in there, and I didn't even find the total this time. So to find the total, we do 8 minus 2 times 180. Okay, 6 times 180 equals 1080. So total 1080 degrees are inside of an octagon. Okay. Each angle, we figured that out when we did this. Each angle had 135. So each of the 8 angles has 135. When I add up all the 135s, I get to 1080 total in the octagon. All right, a little bit longer video today, but hey, we actually did math today, so that's an upgrade for what we normally do in here, right? Normally it's just proofs and different things like that, but today we had just a little bit of a math class in math class. So hope you enjoyed that. If you missed anything, go back, rewind. The big things that you really need to know are the whole idea with the n. N is the number of sides or the number of angles, and then these formulas. The n minus 2 over n, and it's times 180 to give you your number of degrees. Okay? All right, we'll see you later. Have a good one. Bye-bye.